Hello, this video is about the distance formula, and we're going to be working with a PowerPoint that was originally created by Karen Harrington, and I've modified it for my own uses. So I'd like to give props to Karen Harrington for her work on this original PowerPoint. Now, when you've got 2 points on the coordinate plane, any 2 points on the coordinate plane, if you want to find the distance between those 2 points, you need to work with the Pythagorean Theorem. And to do that, we start off by labeling that length as d for distance. And you'll notice that whenever you have a line on the coordinate plane, whether it be like this, like that, you're going to be able to form a triangle out of it, a right triangle out of it. And when you form that right triangle, if you could find the length of this side and the length of that side, you could use that information in the Pythagorean theorem to solve for the missing side. So to find the length of this line here, we work with the x value. The x value of x2 is all the way out here, and that'll tell us the length from here to here. The first x value tells us the length from here to here. If I find the difference between those 2 lengths, I will have this length here. x2 minus x1 is going to give me the length of that line there. I can do the same thing with the vertical line here with the y values. The difference between this y value here and this y value here is going to give me the length of this line here. So now that I have those 2 lengths, I work with the c squared equals a squared plus b squared. Now I know in my class, I have this written the other way around with the c squared in the end. It's still the same formula. All right, but now instead of solving for c, we're going to be wanting to look for d. So we change this to d squared instead of c squared. Now, a, I could make this a or this a. It doesn't matter. I'm going to work with the blue one being a. So we're going to say that the x2 minus x1 is the a value, which means we're going to replace a squared with x2 minus x1 squared. We're going to replace the b with y2 minus y1 squared. Basically, this distance squared times that distance squared will give us this distance squared. Now, whenever you're solving a Pythagorean theorem problem for the hypotenuse here, you need to square the 2 values, add them together, and then do the square root to get the result. So right now, here I've got d squared, but I really want just plain d. So what I need to do is do the square root of this side in order to get the value of the distance. All right, so here, if you're given 2 points, this is the formula you would use to find the distance between the 2. Now, as it turns out, it doesn't really matter whether x1 and x2 are switching places or y1 and y2 switch places, just like it didn't matter when we did the slope formula. Because if you do it one way, you'll end up with a positive. If you do it the other way, you'll end up with a negative, but the same value, the same absolute value. So when you go to square it, it doesn't matter whether you have the positive or negative here. When you square it, it's going to give you the same value. So these little subscripts don't really mean anything at all. You can just subtract the 2 x values, subtract the 2 y values, square both results, add them together, square root, you've got your distance. And this is what's known as the distance formula. Let's go through an example. Here we're given 2 points, 3, 1 and 2, 4, and we're asked to find the distance between them. We use the formula. We're going to call this x1, this y1 because they're the first point we see, and this x2 and that y2 because it's the second point we see. Now, we go to plug it in. We got to have that square root there, open parentheses. We replace this x2 with that value. So that 2 comes down here. Replace, well, bring down the minus sign. Replace the x1 with the x1 value from there. Square that. We're going to be adding that to the y2 value bringing that y2 value down here, the 4, subtracting the y1 value from it, and squaring the result. So now we simplify this. 2 minus 3 is negative 1. If I'd done 3 minus 2, I would have gotten positive 1. And when I square both of those, I get an answer of 1. So again, it doesn't really matter what order I put these in, as long as these are both the x's and these are both the y values. 4 minus 1 gives you 3, and 3 squared is what we're going to have underneath. Now we have to do the squaring here. We do the squaring, we're going to get 1 plus 9, because 3 squared is 9. Add those together, you get 10. You do the square root of 10, and you've got, in your calculator of course, you get 3.1622766 dot 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 dot. And you would round according to whatever the question asks you to round to. So these can work out to be decimal values. Another example. Now this example is important. We're going to see because we've got some negative coordinates in there, and that kind of throws some things off sometimes. At least some students find it difficult. The math is still the same. The formula is still the same. We still work with that same formula there. We still have x1, y1, x2, y2. When we plug it in, we're going to replace the x2 with the 2 here. Replace the negative. We'll move the negative down. We're going to replace the x1 with the 2. And we're going to square it. Now, that's no different. Positive numbers, no problem here. Over here, when we plug in the y2, we're plugging in a negative 1. We have to bring that sign with it. We're going to subtract the y1 from it, the y2 minus the y1. When we go to subtract that, we're subtracting a negative. Oops, problem here. Remember, when we bring a negative in here and subtracting the negative, you've got to put the set of parentheses in here, because subtracting the negative becomes addition. And we're going to square that. So this becomes 2 minus 2, which is 0, 0 squared. This simplifies to negative 1 plus 7, which gives you 6. And you're going to square the result there. 0 squared is 0. 6 squared is going to give you 36. Add those together, you end up with the square root of 36, and the square root of 36 is 6. So there's your distance. Pause the video, give these 3 a try using the distance formula, these 4 a try using the distance formula, and I'll come back with the answers. Welcome back. All right, this time I'm not going to go through all the steps on it, I'm just going to post the answers. The answer number 1 is 5. If you do 4 minus 1, you get 3. 3 minus a minus 1 becomes 4. So you end up with 3 squared plus 4 squared, which is 9 plus 16, which is 25. And the square root of 25 is 5. Here you get 6.7. 2 minus a minus 4 gives you a positive 6 for the y. 3 minus 0 gives you 3. So you end up with 9 plus 36, which is 45, and the square root of 45 ends up giving you 6.7. The next one has an answer of 5.7, and the last one has an answer of 11. See you in class.